Preparing for a MongoDB Database Engineer interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What are the main differences between MongoDB and a relational database? MongoDB stores data as flexible BSON documents, while relational databases organize information into tables with predefined schemas. I would choose MongoDB when the application benefits from nested data, rapid schema evolution, or horizontal scaling across many nodes. Relational systems may be better for highly normalized data and complex joins. MongoDB now supports multi-document transactions, so the distinction is not simply transactions versus no transactions, it is primarily about data modeling, access patterns, and operational requirements. While answering, focus on document-oriented storage, flexible schemas, embedded data, joins, transactions, horizontal scaling, query patterns, and why workload requirements, not technology preference alone, should determine the database choice. Question 2. How would you model relationships in MongoDB? I model relationships around how the application reads and updates data. I embed tightly related, bounded data when it is usually retrieved together, such as an order and its line items. I reference large, frequently changing, or independently queried entities, such as users and transactions. I also consider the 16 megabytes document limit, write amplification, and consistency. Controlled denormalization is acceptable when faster reads outweigh the cost of synchronizing duplicated fields. Make sure to cover embedding versus referencing, cardinality, document growth, read and write patterns, update frequency, bounded arrays, consistency requirements, and the possibility of duplicating data deliberately for performance. Question 3. What is the MongoDB document size limit, and how would you handle large documents? MongoDB limits a single BSON document to 16 megabytes. I would first prevent unbounded document growth by moving large or repeating data into separate collections and referencing it. For files larger than the limit, GridFS is an option because it stores content in chunks with metadata. I would also review whether historical records belong in an archive or bucket collection. The key is designing bounded documents before production, rather than discovering the limit during writes. In your answer, talk about the 16 megabytes BSON limit, unbounded arrays, GridFS, referencing, bucket patterns, archival strategies, and how access patterns influence whether data should remain together or be separated. Question 4. How do indexes work in MongoDB, and what makes a good index? An index provides an alternate access path so MongoDB can locate matching documents without scanning the entire collection. I design compound indexes according to query patterns, commonly placing equality fields first, followed by sort fields and then range fields. I check selectivity, index size, write overhead, and whether the query can be covered. I validate the design with explain and realistic workloads, because an index that looks logical may still be inefficient. Be sure to mention query selectivity, equality sort range ordering, compound indexes, covered queries, index storage and write costs, prefix behavior, and validating decisions with explain plans and production-like data. Question 5. How would you troubleshoot a slow MongoDB query? I would capture the exact query, parameters, collection size, and workload conditions first. Then I would run explain with execution statistics and look for COLLSCAN, excessive documents examined, blocking sorts, poor selectivity, or rejected plans. I would review indexes and query shape, then test a targeted change against production-like data. Finally, I would monitor latency and resource usage after deployment, since a faster isolated query can still increase write cost or memory pressure. While answering, focus on reproducing the issue, using explain execution statistics, checking collection scans, rejected plans, sort stages, selectivity, index effectiveness, server metrics, and confirming improvements under representative concurrency. Question 6. What is the aggregation framework, and when would you use it? The aggregation framework processes documents through a sequence of stages, such as match, project, group, sort, and lookup. I use it for server-side transformations, reporting, analytics, and reshaping results without transferring unnecessary data to the application. I place selective match stages early in project-only needed fields. I watch memory and sort behavior, and I consider pre-computed summaries for expensive recurring reports. Explain plans and execution metrics guide optimization. In your answer, talk about pipeline stages, filtering early, projections, grouping, sorting, lookups, memory limits, allow disk use, indexes, and deciding whether recurring analytics belong in pre-computed collections. Question 7. Explain MongoDB replica sets and how they provide high availability. A replica set is a group of MongoDB instances maintaining the same dataset through oplog-based replication. One eligible member is primary and accepts writes. Secondaries replicate changes and can become primary after an election. I typically deploy multiple voting members across failure domains and use majority write concern for stronger durability. Read preference should match consistency needs, because secondary reads can be stale. Monitoring replication lag and election behavior is essential. Make sure to cover primary and secondary members, oplog replication, elections, read preferences, write concerns, majority acknowledgement, priority, hidden members, and the operational importance of an odd voting configuration. Question 8. What happens during a MongoDB primary election? When secondaries determine that the primary is unavailable, eligible members hold an election and a candidate must obtain a majority of votes. The winning member becomes primary for a new term, after which clients reconnect and resume writes. During the transition, writes may briefly fail, so applications should use modern drivers, retrievable writes where appropriate, and sensible timeouts. I also investigate the cause of the election, because repeated elections indicate infrastructure or configuration problems. Be sure to mention failure detection, majority voting, terms, priority, temporary write unavailability, retrievable writes, driver behavior, election timing, and designing applications to tolerate brief topology changes safely. Question 9. How do read preference and read concern differ? Read preference determines where a read is sent, such as the primary, a secondary, or the nearest eligible member. Read concern determines what level of data visibility the operation requires, such as local, majority, snapshot, or linearizable behavior. For example, secondary preferred may reduce primary load but return stale data. I choose both deliberately. User-facing critical reads may require primary and stronger concern, while dashboards may accept secondary, locally available results. While answering, focus on read preference selecting the server location and read concern defining visibility guarantees, including primary, secondary, local, majority, linearizable, snapshot, and latency or consistency trade-offs. Question 10. What is sharding, and how would you choose a shard key? Sharding distributes a collection across multiple servers so storage and throughput can scale horizontally. I choose a shard key using cardinality, distribution, write frequency, and the most common query patterns. A monotonically increasing key can create a hot shard, while a hashed key distributes writes but may reduce range query targeting. I test realistic traffic and growth assumptions because changing a shard key later is disruptive. Avoiding scatter-gather queries is a major design objective. Make sure to cover horizontal partitioning, shard key cardinality, frequency, monotonicity, distribution, query targeting, scatter-gather operations, workload balance, hashed versus ranged keys, and the consequences of changing a poor choice. Question 11. What is a chunk migration, and what problems can it cause? A chunk migration moves a range of sharded data from one shard to another to improve balance. MongoDB coordinates the donor and recipient while applications continue operating, but migration consumes network, disk, and CPU resources and can increase latency. I would monitor balancer activity, replication lag, queue depth, and query performance. Jumbo chunks or a poor shard key can prevent effective balancing. I would address root causes rather than repeatedly forcing migrations. In your answer, talk about balancing, chunk movement, donor and recipient shards, migration overhead, replication lag, lock or I/O pressure, jumbo chunks, monitoring, and scheduling maintenance during appropriate capacity windows. Question 12. How do MongoDB transactions work, and when should you avoid them? MongoDB writes to a single document are atomic, so I first try to model related state together. Multi-document transactions provide atomicity across documents or collections when a business operation truly requires it. They add coordination, locking or conflict risk, resource usage, and latency, so I avoid using them as a substitute for thoughtful modeling. I keep transactions short, handle transient errors with driver-supported retry patterns, and verify whether majority durability is required. Be sure to mention single document atomicity, multi-document transactions, snapshot behavior, lifetime and size considerations, latency, write conflicts, retry logic, and preferring a data model that minimizes transactional boundaries. Question 13. How would you implement and test a MongoDB backup strategy? I begin with defined RPO and RTO targets, then select backups accordingly. For a managed deployment, continuous cloud backups or snapshots may provide point-in-time recovery. Self-managed systems may use file system or logical tools plus oplog capture. Backups must be encrypted, access controlled, retained appropriately, and copied across failure domains. Most importantly, I regularly restore them into an isolated environment, validate application usability, and measure recovery time rather than assuming a successful backup implies recoverability. While answering, focus on recovery point and recovery time objectives, logical versus physical backups, managed snapshots, oplog or point-in-time recovery, encryption, cross-region copies, restore testing, and documenting recovery procedures. Question 14. Which MongoDB metrics would you monitor in production? I monitor both database health and user impact. Core signals include read and write latency, throughput, errors, connections, CPU, memory, disk utilization, I/O latency, cache pressure, and queued operations. For replica sets, I track replication lag, election events, oplog window, and member health. For sharded systems, I add chunk balance and router errors. Alerts should reflect sustained, meaningful thresholds and be linked to runbooks, not merely generate noise. In your answer, talk about operation latency, throughput, errors, connections, CPU, memory, cache behavior, disk I/O, queuing, replication lag, elections, op counters, and alert thresholds tied to customer impact. Question 15. How would you diagnose replication lag? I would identify whether lag is caused by the primary producing changes too quickly or a secondary applying them too slowly. I would inspect replication info, oplog window, network latency, disk I/O, CPU, cache pressure, long-running queries, and secondary-only workloads. I would confirm indexes support replicated reads and check for flow control effects. Remediation might include removing competing workloads, improving storage, scaling appropriately, or reinitializing a damaged member safely. Make sure to cover measuring lag across members, primary workload, secondary resources, network latency, oplog capacity, long-running operations, indexes, flow control, hidden workloads, and safe remediation without causing data loss. Question 16. What is the oplog, and why is its window important? The oplog is a special collection containing ordered write operations that secondaries apply to replicate the primary. Its window represents how far behind a secondary can fall before missing required history. I size it from peak write volume and expected maintenance or outage duration, then monitor the oldest timestamp and lag. If a member falls outside the window, it generally requires an initial sync. A healthy window supports resilience, maintenance, and point-in-time recovery. Be sure to mention the capped replication log, operation history, secondary catch-up, rollback implications, sizing based on write volume, maintenance duration, lag monitoring, and why a short window threatens recoverability. Question 17. How do you secure a MongoDB deployment? I secure MongoDB in layers. I enable strong authentication, role-based authorization, TLS for client and member traffic, encryption at rest, and private network access rather than public exposure. Applications receive narrowly scoped credentials, with secrets stored in a managed vault and rotated regularly. I enable auditing where required, patch supported versions, protect backups, and monitor access. I also test failed login, privilege boundary, certificate rotation, and disaster recovery scenarios to verify the controls. While answering, focus on authentication, authorization, TLS, encryption at rest, network isolation, least privilege, secret management, auditing, patching, backups, exposure prevention, and validating controls through testing. Question 18. What is the difference between a unique index and a partial index? A unique index prevents duplicate indexed values across the documents it covers. A partial index covers only documents matching a specified filter, which reduces size and targets a workload. It can also be unique within that subset. For example, I might enforce unique active email addresses while allowing historical records to reuse them after soft deletion. I would check missing and null semantics carefully and ensure queries include compatible predicates so the optimizer can use the index. In your answer, talk about uniqueness enforcement, filtered index membership, sparse behavior, null and missing fields, soft deletes, conditional constraints, query compatibility, and confirming that application predicates align with the index filter. Question 19. How would you perform a zero-downtime MongoDB schema change? I use an expand-migrate contract approach. First, I add the new field or index in a backward-compatible way and deploy application code that can read both formats. Then I dual write or backfill in controlled batches, monitoring load and correctness. After validation, I switch reads with a feature flag, stop writing the legacy field, and eventually remove it during a later release. I keep rollback paths available throughout and avoid blocking production traffic with a massive migration. Make sure to cover backward-compatible expansion, dual reads or writes, lazy or background migration, feature flags, validation, rollback, index rollout, version compatibility, and removing legacy fields only after all clients migrate. Question 20. A MongoDB application suddenly experiences high latency. What is your investigation process? I first establish when the latency began, which operations and users are affected, and whether errors or throughput changed. I check dashboards, profiler samples, slow queries, query plans, connection pools, CPU, memory, disk latency, locks, replication lag, elections, and dependent services. I mitigate safely by reverting a recent change, throttling a workload, or routing reads appropriately. After recovery, I reproduce the issue, identify the root cause, document the timeline, and add tests or alerts to prevent recurrence. Be sure to mention scope and timing, recent changes, query profiler data, explain plans, infrastructure saturation, locks or queues, replication and elections, connection pools, dependencies, mitigation, and post-incident prevention. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.